Today, we're going to do a 12-point comparison of the Standard Model versus the keyring atom. And we're going to look at it from physics, a physical point of view. Real, physical, not magical. Now, the first thing that we do a comparison, Standard Model, proton, does it have a core? Studied that, they know that. Yes. Standard Model passes the first one. Does the keyring atom have a core? Yes, called a proton ring. So, both pass the first one. Second thing, if there's a cloud that goes around the core, does the orbiting electron produce the cloud? Supposedly traveling at the speed of light? Yes. Passes that particular thing. That would produce a cloud. Does the keyring atom have a cloud? Yes. Instead of one electron ring, it has thousands of electron rings circling around it. So both pass the cloud. Now, physics, physical. Does the proton and the electron have a physical connection? This one fails. Why? It's called electromagnetic force, and somehow this positive and negative charge causes it to hold in the cloud. It's not a physical connection. This fails. Does the keyring atom, does that hold? Is that a physical connection? It passes. Now, one of the other things they found in an atom, it has a top and a bottom. This orbiting ball that does this wave movement or whatever else, is there any answer that adequately explains the physical top? No, it fails. Does the keyring atom have a top? All the electron rings are circling one way? Yes, it has a top. It passes. The next thing they know is an atom has a bottom. Does this adequately explain why the atom has a bottom? No, fails. Does the keyring atom explain the bottom? Yeah. All the electron rings are circling in one way, they're coming out the other. It's going to have a different way that orients itself. This is going to have a bottom. Passes. Wave movement. They see a wave movement inside of the atom. Now, on the Standard Model, that means this thing isn't just circling around the outside orbiting. That means it's moving in a wave. Does that explain it? No, it fails. How can the force produce the pull on that to make it move in a wave? However, in the keyring atom, if you take a picture and you catch this ring right here on the side, what are you going to do? You're going to see part of a wave. If you catch it moving on the other side, what are you going to do? Look at it this way. You can see a wave in there. If you look at another angle, you can see a wave in there. That's why they see waves inside the atom. Standard Model fails, keyring atom passes. Now, whenever they smash an atom, particles, all kinds of particles come out everywhere. Does this explain that? You bust a proton and it turns into particles? Why don't they see proton chunks? Supposed to be quarks and bosons. How much of that stuff do they see? They really have no idea. You don't see big chunks and little chunks. You see all little energy particles. Standard Model fails on that. Keyring atom, you break this ring right here, all the little particles that are spinning, bang, they're all coming out. This model passes, this model fails. Temperature. Right, what causes temperature in the Standard Model? It's supposed to vibrate. The hotter it gets, the more it vibrates. All right, what are the laws of physics? An object in motion tends to stay in motion. So if this was in motion, why would it stop? What's going to stop it? Now, if it goes over here and it's vibrating, it has to stop. and speed back up. Well, what's the other law of physics? An object at rest tends to stay at rest. This is a total failure. It defies two laws of physics if that's how temperature happens. Key ring atom, what causes hot and cold in temperature? As it gets hotter, the electron rings get bigger, and it'll be more bouncy. It's going to have more energy in it, and if it gets colder, it's going to get smaller and tighter. This passes this. The standard model on temperature is a super colossal failure. Next thing is inertia. What do they got in the standard model? They're looking for the Higgs boson. It's like the lost city of gold. They keep looking for it, but they never find it. Well, they might have found something that might be the Higgs boson, but they're not sure. So they get more money. It's a money maker looking for the Higgs boson, and that's what's supposed to cause inertia. Now, what about the key ring atom? Gravity. It has a gravity particle that goes through it. And like if you have a lot of atoms, you have particles that come from all directions. That holds you in place, that holds your speed, that's what causes the inertia. Failure, pass. Gravity at the molecular level. Has the standard model ever explained that in the 100 years that it's been around? No. It's a failure, known failure, no doubt from anybody on that. However, with the key ring atom, you have a hole. You have circling particles. Particles can now go through the center. And once that start going through the center, any other atom that comes into contact with that stream is going to be pushed that way. This explains gravity at the molecular level very good. Key ring atom passes on gravity at the molecular level. Standard model fails. Why do atoms stick together? What's the physical connection? You have a proton, hydrogen, and you have an isotope, deuterium. This is a proton. This is a neutron, neutral charge. Strong force is supposed to hold that together. Why does a neutral charge stick to a positive charge? Shouldn't. Neutral shouldn't stick to anything. Then if you go all the way up to a helium, now you add another proton and another neutron. Now you got two positive charges, this magical strong force. Now they're supposed to be held together. Why would two positive charges stick together? It's illogical. They should blow themselves apart. By definition, this shouldn't even stick together. Fails. However, with the key ring atom, just like the key ring, you put multiple key rings together, they physically hold together, like this deuterium, sticks together. If you go all the way up to a helium, and you hook 4 of them together, you get this, they stick together. The key ring atom passes. The standard model fails, blows apart. How do compounds hold together? Standard model. You have all these orbiting balls, and they have something called valence shells. So this is water. Somehow, this magic force, this electromagic force, it goes this wavelength thing here anyway that they try to explain, somehow also orbits and does a wavelength thing around this one. So if you were going to make water, you were going to take oxygen, and you're going to take 2 of these, and you're going to hook them on there, and you got these wavy orbiting balls. Does that explain anything? Does that make sense? Fails. It's a failure. There is no physical connection. However, the key ring atom, this is an oxygen. We already hooked a hydrogen here for water. Hook this one up, shared electron ring, like so. Physical connection. Physically holds together. The key ring atom explains compounds. The Standard Model fails. All right, we're going to do a model comparison of two bridges with different geometry. Each of these two bridges has 49 toothpicks in it, same number of glue, same number horizontal and vertical, whichever way you look at them, to do the two bridges. So now we're going to put them under a stress test. Got $20 worth of quarters here. Notice the bridge holds. Now if we take them over here, put them on this bridge, notice it's already starting to fail. We put them on the second one and they'll load. The bridge fails. That's the difference in geometry. Which of these models would you use to drive your car across town? One that works or one that fails? You saw the bridges. You saw the failure. Now, we compared two atoms. One failed. The Standard Model failed in 10 out of 12 tests that we put it through. The keyring atom on the physical connections, not theoretical, physical connections of physical things that you can make and you can see, it passed 12 out of 12. Now, which one would you base your ideas in physics on? One with failure or one with success? Why is this so successful? It's because physics and chemistry are easy with the correct geometry.